Okay, well, welcome to today's show. Today, we're extremely privileged to host a true pioneer of technology, Anish Mohammed. Welcome, sir. Anish's career spans over 2 decades in security and cryptography, starting with his role in Ericsson HP Telecom, where he worked on securing micropayment systems, which later he pivoted into his ZKP knowledge. Over his career, by the way, just as an introduction to his introduction, I spent about 2 hours yesterday totally stalking with Agent GPT. Anish. So apologies ahead of time. Anish has lent his expertise to 3 different research groups, including Microsoft Research, delving into cryptographic algorithms and protocols. His knowledge and guidance has been sought by like the biggest in the industry, such as AIB, HSBC, Lloyd's, and Zurich. He was instrumental in the early stages of Ripple, acting as an advisor to their team. In fact, Stephen Thomas, the CTO of Ripple, has described Anish as a true pioneer of technology, always clued in and ready to bounce off the latest ideas in cryptography, blockchain, and big data. He's known for his wide-ranging multidisciplinary background with a ton of companies. If you want to take a look at his LinkedIn, his academic journey is also massive. He has a PhD in informational security from Royal Holloway, University of London, where he studied from in the early 2000s. He attended the Ignite program for innovation and entrepreneurship at Stanford. He studied at MIT, focusing on the challenges of big data and data science at General Assembly. He's also an alum of the prestigious Singularity University, where he was part of a graduate program that was just offered to 80 people each year, where he studied like a wide-ranging array of fields, including robotics, AI, biotech, neuroscience. He also attended Singularity University's Future Med program, exploring like how developing tech shape the future of health and medicine. You also have an MBBS degree in medicine from Medical College at Trivandrum and a Master of Science in Informational Security. So welcome to the show. It's an honor to talk to you, sir.
Okay, thank you very much. It's very kind.
Your current position is at Panther Protocol, where you are a co-founder and CTO, where you've been intricately involved in protocol design of zero knowledge proofs since November 20. So we're happy to have you here.
Thank you.
When we were sort of gearing up our show like a couple minutes ago, we kind of already dove off into the deep waters. But you're coming off of a panel at Zulazu, where you spoke about existential risk and AI. So maybe we can, you can highlight some of the key takeaways that you shared there.
Sure. So, just full disclosure. So there were a series of panels and a series of events. I just happened to be like, a moderator and a panel member for 2 sets of them. And then there was always this ongoing conversation that was happening with a lot of people, right? So what has happened is the people who are organizing this happen to be my friends. So I ended up getting invited to give a talk and a panel. And then they were asking about, okay, could you do this? Could you do that? So what I would describe it as Zuzadu was a very interesting social experiment. That's how I would describe. And the social experiment was kind of subsidized by Vitalik. So he offered to, spend up a bunch of his money to take over a hotel called Chetty and a bunch of apartments in Montenegro. And what had happened is there were workshops on series of topics that was happening. So in my mind, I was very much interested in probably staying as much as I could. But because I have a team to run and other interests on the side, I definitely couldn't afford to do that. So, and this wasn't really very well advertised in that sense, because Nima, one of the people who was organizing this, and through him, Vish and other people that were involved in organizing the whole AI blockchain thing. Then I ended up, getting a couple of my other friends to come in, like Jan and a couple of other people. So that's how I got dragged into it. So the overall difference that I would say, in summary, that has happened in Zuzalu was, if you were to go back in 10 years and if you were to think about Machine Intelligence Research Institute, so Michael, who was one of the people who were involved in the start of the Machine Intelligence Research Institute, was there as well. Jan was there, Jan Talon was there. So Jan is quite a vocal, I could say, person who has been involved in putting in a lot of research institutes, and also making sure he puts the money where his mouth is. When I say that, I really mean it. As in, like, he was a key person behind Future Life Institute, Center for Existential Risk, Future Humanities Institute. So I have first-hand knowledge about Future Humanities Institute because a bunch of the people that in the existential risk community happened there. Nick Bostrom is there, Anders Sandberg is there, Eric Drexler is there, and Anders happened to be a good friend of mine. And over the years, when I was in London, over the weekends, every Saturday, I would go and spend a couple of hours with those guys, because it's quite interesting to understand and see where things are. So, what you could literally see. So this is the other part of it. It's not just the researchers saying this. This is, people who are in the industry saying the same thing, right? So if you think about this, Imad was there, Imad Mushtaq. So again, Imad was somebody who I had known over the years in London. Now he's a well-known figure in the AI space, which is quite helpful. Knowing people before they become famous gives you this ability to measure how much of a change that the celebrity status makes on them, especially in a frame of reference and how they think. And what was interesting was, what Imad was more or less talking about was almost on the same page as what Jan was talking about in terms of understanding existential risk. There might be differences in the way that each of them might approach it, but it is quite interesting to see that over the last 10 years, people who have had very different views have all come together. It has become closer and closer. And now we reached a point where a lot of them can actually exchange messages. And this is what I was talking to both of you before. This smaller tribe that existed, the tribe of existential risk that existed like 10 years ago, the vocabulary was hardly ever understood by anybody possibly outside, other than the Stuart Armstrongs of the world, or Nick Bostrom's of the world, or Nick Soros, or somebody like, all the people that are there, the hardcore people. Everybody outside would have actually seen this as like a strange thing. But now, I won't be surprised if, for example, Superintelligence by Nick Bostrom gets to like the top 10 list in Amazon, right? Or some other, book list place, right? And people start understanding the paperclip optimization paradigm and other things in that sense, and start talking about it. So this is the real difference I saw. Like, a lot of people who understood a reasonable amount of math, a reasonable amount of machine learning, who had an amount of cynicism, now has actually changed. So there's a funny story I could give you an example of. So before I was supposed to fly in, they were trying. There's a couple of people that are very interesting people. There's Christian, who used to work for Neuralink, essentially one of Elon's company. He wanted to have a panel. So Nick Soos was there. He's actually the guy who now runs MIRI, Machine Intelligence Research Institute, which I was describing previously. And they wanted to have a debate between somebody who's an accelerationist and X person. Because we had no accelerationist in place, they asked me if I'd be willing to take a bullet for the team. I said, as long as you specifically explain this is a debate and I'm taking this position, I'm happy to do it. So before I reached there, somebody else volunteered, so I was saved from that one. So that is the thing that we need to recognize. If it was 10 years ago, there would have been no difficulty in finding somebody to be an accelerationist and pick up a debate with Nick Soos in that sense. So that's the context I should share with you, so you understand where we stand and how things conversation there.
Okay, so for some of the listeners who aren't familiar with the paperclip hypothesis, let's let's dive in that just as it relates to existential risk.
Yeah, I mean, the thing I was about to say was like, to me, I take a whole bunch of things as like for granted, right? So typical paperclip optimization thing is the general class of all problems where, I kind of, extend that to the whole machine ethics paradigm in that sense. So imagine, okay, let's think this through as a human mental decision process, as a mental models, human decision biases, machine learning, machine learning biases, and typical what a machine learning process looks like, and what would be the difference. And then we will get to this paperclip optimization thing, and then
well, perhaps I sometimes in the interview I kind of go for a rabbit hole, but Hamilton, why don't you pan us out a little bit before we go down all that?
Okay.
I was interested. I was interested in going down the rabbit hole. I was transfixed right then.
Okay.
Like
Okay.
I'll so succinctly. I want to go into the rabbit hole to understand these different layers, because on the zoom out, people go, oh, they throw up their hands. I mean, I'll be, I'll represent right now the 1 billion people who are just sitting in fear, right? They're just shaking in fear, and they have no thought about it other than what's been propagandized to them. Right. And so I think it's important to understand that to describe any aspect of these problems, it's actually really sophisticated, intricate, multi-layered, faceted. And there yet that we don't know, at least that I know of, and correct me if I'm wrong, there isn't some mastermind super out there in some silicon form that is representing the existential risks to us right now, like representing the other that's going to come kill everybody. So that's the zoom out. We're not talking about that. We're talking about something much more sophisticated than that.
Yeah, so the way I wanted to describe was I wanted to give this larger picture, right? Let's start with the larger picture. Explain what a typical machine learning algorithm is, how a human decision process works. So
also, sorry, just pull the mic a little bit closer to your mouth.
Oh, really?
Yeah.
Okay.
Yeah.
Is it better now?
There. Thank you.
Okay. All right. So I wanted to just make sure that it's described in a larger context, so everybody can actually think through this with very limited amount of mathematical sophistication. And then, if somebody wants to really go in, they should be able to go do that better. So the thing I was describing is like, imagine a world, okay? Imagine a world where we decide, and this is a game that we create, right? Could be a game created with humans or without humans, or could be machines, or machine in the sense AGIs or AIs, right? Or like hybrids, right? We could actually have all three. So I should probably say, for the readers who are kind of interested in this paradigm where humans cross over to hybrids, I've given a talk in 2016, kind of, I know this is like a silly thing to say, like kind of said all those things that's kind of become very relevant now. Now that's like 6 or 7 years in the making. So the talk was at the Rise of AI in Berlin. So again, my good friend Trent gave the other part of the talk. The other half of the talk was about simulation, how humans could actually go into silica. So let's going back into this game, and the game has been constructed by either humans or machine, the other human machine hybrids, right? And you said the rules of the game. Now the question here is like, when you have rules of the game, and this is like typically when humans make decisions, humans have a lot of biases, right? So for example, now that Nathan has actually given like a brief history of what I've done, there's an anchoring phenomenon. So even if I talk nonsense, there is this small sense of bias, people to think that this guy is not talking complete and utter nonsense. He's saying something we don't understand. That's not actually true. Could be the fact that I am just talking nonsense, right? But if you were to take a machine and like think of it like a very simple machine, machine learning algorithm, right? Y equals mx plus c kind of thing, like a very straightforward linear equation, right? So that is pretty straightforward. It takes the data, does a process. It takes x and gives a y, right? So that's a pretty straightforward one. And if the rules of the game is whoever who sticks to the game wins, then as you could recognize, because the humans have a decision bias, machines are always going to win. So if you even have like a very simple criteria of a game, where the game's optimization function is that stick to the gains of the rule, humans fail. And this is kind of loosely speaking what we could think of as like a, in a meta level, a paperclip optimization in that sense.
Okay, understood. With you.
So yeah, this is the start of the story. So in general, what I would describe is like most of the machine learning processes are stochastic processes, and in that sense, and the learning in that sense is typically that of a stochastic gradient descent. So essentially, you have a position where you are in, you want to go down, and like imagine this as like you are at top of a hill, and you want to make sure you're kind of in the dark, right? Let's think of it that way. Like you climbed up a hill, and you're at the top of the hill. You know you're at the top of the hill, right? At least that's the assumption. And now it's become dark, and you have to climb down, right? As you climb down, you want to make sure when you finish your climbing, you're at the bottom of the hill or the valley, right? So you want to actually make sure that you are, whenever you get to a stop, you want to make sure that the valley you are in is the lowest valley. So you try to find a place, and you measure your height, and then go in each direction and make sure no other direction has a lower value than what you have. But even then, that is possibly like a small valley that's there, and you got stuck and you didn't explore it enough. So this is typically like the problem that machine learning algorithms normally have. The trade-off between local maxima and a global maxima, or local minima and a global minima, right? And this is very interesting in a very meta sense. What I mean by that is like, if you were to think about all this machine learning stuff that's happening, and like, they're evolving and making assumptions of we've evolved to a particular state. We are in no place to fully understand where we are, and we are at a place where we really reached where we should be reaching. We're still making assumptions and still trying to figure out what's happening. And at the same time, the other side I typically describe to people, and this is like a slightly contrarian way of thinking, but I need to give you some context. So Len Edelman actually had a paper, and the paper was described as combinatorial molecular solution to combinatorial problems. Okay, this is a very interesting construct. I mean, I wanted to give you this construct so both sides of this equation that is kind of understood, and like see how evolution happens in the nature and how computational processes happen. And I'm just describing the computational process as a stochastic process, and I give you like a notion of how that happens. And I want to give you a similar process that happens in a biological sense, and how the biological process at times seems to have better solutions, right? So let me explain it a bit better. So there's this construct called a traveling salesman problem. The easiest way to describe it is like, imagine there are 5 cities that a traveling salesman need to actually visit, and the problem is to optimize the total amount of driving that he or she has to do. This is considered a non-polynomially complete problem, NP complete problem, right? And what Len Edelman proved in that paper is like you could actually use biology to solve this problem, and solve this NP complete problem in a very reasonable time, right? And this paper is called Molecular Solution to Combinatorial Problems, right? So this is like quite an interesting construct. So what it's showing to us is like there are mechanisms in biology which probably, through years of, millions of years of selection. So you should think of this, this problem solution, which is like taking 2 arbitrary strings of DNA, or DNA strands, if I'm not mistaken, and then you hybridize, and you do enough of hybridization until the largest fraction of the DNA is of the same, sequence. Then that largest fraction of the sequence is the solution to the problem, right? So if this has been the way to solve an NP complete problem, and this has been the solution that nature has been applying to solve this problem, and nature has been consistently doing this for millions of years, probably the solution set that we have in nature could be as close to optimal as possible. Again, we don't have theoretical bounds to all these things. So, we have a very interesting evolutionary computational mechanism that exists. In some ways could be close to optimal. We don't know, right? And then there is this a whole bunch of math just trying to solve a bunch of problems, and each of them are competing against each other. And now one of the challenges we have is like, we don't know which one would actually win the race, right? It's almost like a Zeno's paradox in one sense of speaking. I hope everybody who listens to this understands the construct of Zeno's paradox. Before calculus was there, this race between a tortoise and a hare was a big problem, because the math at the point in time never was able to show that the hare would actually cross the tortoise if the tortoise actually started, or turtle if it started early, right? So that's a Zeno's paradox. So this is like almost this phase where we are stuck between the two, trying to figure out when this crossover is going to happen. When it happens, how does it happen? So it's kind of a very interesting, multi-sided, multifaceted, interesting paradigm in my head.
I'm going to link to that paper in the show notes. Hamilton, would you give a follow-up question in relation to that particular problem that Lynn Adelman was solving? Anish, maybe you can explain. I don't quite understand it myself. So Lynn basically said that there are math problems that we don't know how to solve that biology has solved. Is that right?
Yes, I mean, so that's one way to think about it. So there is this classes of complexity. So polynomial and non-polynomial. Non-polynomial means as the number of constraints increases. So when we were talking about the traveling salesman problem, imagine we had like 5 cities and the complexity of solving it is like 10. If you increase it to 10, the complexity of solving that might become 100 or more than that, right? So it's a non-linear in that sense. That's the hardness in a traditional sense. What biology is in this instance using DNA has shown us is like there are mechanisms that exist that can possibly give you interesting solutions. I mean, I don't know how, energy-wise, how optimal that is. So again, this is the paradigm we need to understand. Like, we have like a bunch of competing paradigms that are there at the same time, and like each of them are competing against each other. So we have a biological paradigm of computation in our brain, which seems to be quite efficient, versus a computational paradigm. So we need to think about the training that we actually have with the large language models and the amount of energy you spend on those things. So it's a very interesting, multi-dimensional paradigm that we are playing around with, and still waiting to see whether the Zeno's, in my head, the Zeno's paradox is true or not. It's kind of a funny way to think about it. Like, until calculus was there, to mathematically prove that a hare and a tortoise were to run, and if the tortoise were to start really early and the hare were to actually come later, this challenge that it actually, even though we know it actually crosses over, it's going to overtake the tortoise. The math at that point in time was pretty hard to prove, right? So this is an interesting construct. So we are kind of looking at it that way. I mean, this is how I'm thinking about it. Like, you have all these interesting constructs that are around, and we don't know. Let's see if it goes across. If it goes across, yeah, okay. Well, now what?
Would you clarify? I'm frankly lost. Would you clarify like what this is in relation to? Like,
okay, so there's humans versus, as in like biological systems versus computational systems, right?
Okay, so the Lynn Adelman papers show that you can do computational systems within molecular biology.
Yes.
Okay.
And evolution in terms of biological evolutions could have been using the same mechanism. So the mechanism that's available when you do molecular DNA hybridization is pretty much what we do when people do genetic experiments, in one sense of speaking. It's a crude way of saying that, but pretty much that's what it is. So if you have hundreds of millions of years of evolution, what that has happened is there's been computation that's been happening. In one sense of speaking, that's like a bunch of computationally NP-complete problems for which biology has been trying to solve to find optimal solutions. And I was looking at the result of the two sets of problems as the Zeno's paradox in one sense of speaking, which is going to overtake the other one, and do we know whether we know it's going to happen or
not? Okay, got it.
Does it ultimately happen in the form of these different hybrids that you're talking about? I mean, one of the things I've been Sorry.
Yeah, I'll be very interested. Sorry. Yeah, I mean, I'll be very interested if that were the case, right? This is again one of the things I have no clue about. I wish I had a clue, right? So to me, the way I think, if human machine hybrids were to exist, again, this has a bunch of societal impact, right? A huge bunch of societal impact. Society has to relearn a whole bunch of things, and the so-called resource allocation paradigm is going to make it really difficult. Let me walk you through a couple. I don't know, I answered your question the right way, and please stop me if I go sideways, because like I have so many things in my head and I want to always explain it to people because I can't write. My only chance to do something is to teach somebody, so that's why I teach at all the places. Anybody who offers me a place to teach, I'm happy to teach grad students. It's mostly a reading course. I give them a bunch of papers, then I go there and explain my thinking. It's easy to fool yourself because I'm a big fan of Feynman, and one of the things Feynman have said is it's easy to fool yourself, but it's it's really hard to actually fool others, especially grad students. They don't really give a shit about who you are. Apologies for the French. Like they will just call you out, and anytime you have a chance to validate your assumptions in front of others, I think you should take it. Because otherwise, you can easily have a wrong assumption and then you build your mental models on top of the other until you reach a point that you bested so much that your loss aversion would prevent you from changing your mental paradigm. So, I mean, as humans, we all have loss aversion. We really don't want to lose something we already have, right? So it's like to reduce the losses, it is always good to test. And then, if the test fails, then you failed. So at least that much loss is reduced. Okay, going back to the thing that we were talking about, this hybrid question. So the hybrid question is the following, right? Firstly, the resources that one requires to actually have an interface is going to be quite high and only be available to a small fraction of the population. That's number one. And the other part is like we already have a bit of a interface, right? That's called a phone is a good interface. The I/O, you have your eye. And eye is one of the highest throughput places. An optic nerve is right in front of us, and optical plexus is just behind us. So we could actually send things out really fast. But reading stuff back out might be the challenge. And it is very possible that we might have solution to this really fast. If that happens, then it's mostly regulatory and other things. And again, we need to understand all of this has lots of socio-political implications. So what I mean to say is like tomorrow, if you had like a very high quality brain computer interface that could allow somebody to interact with the machine, guess the first of the people at your door asking you for this is most likely Pentagon, right? Imagine the advantage one could have if you could interface your brain to your, Gen 6 fighter planes, right? All the drones that you want. You know what I'm saying? Like,
Right.
the implications of that. And then the other side of the equation is like, society has evolved so far with a bunch of norms. That includes like we wearing clothes. Maybe in a nudist colony we may not, but in a normal society, typically we have the concept of clothes, and this has this inherent construct of privacy, right? And we need privacy to have governance structures like democracy and stuff like that. All of this is going to completely disappear in one instance if we actually connect all our brains together, right? Complete and utter social shock in that sense, right? So, one side there's this challenge of resource allocation. The other side there's this challenge of nation states and other people uh, you know looking at this technology as a competitive advantage. And thirdly, there's this societal implications of this thing. So to me, all of these are very interesting things. At the same time, I don't know if this is the path that we are going to take. If we do, that'll be pretty interesting. But there could always be this case that the hair runs past the tortoise, and then we don't even notice that has happened, and suddenly the second order effect of that will come to us. And this is again a game theoretic construct, right? So a good example of this I would normally describe is like there is bug bounties normally published. I'm sure everybody understands bug bounty, right, Nathan? Yes. Okay. So this is typically that you produce a software. The software has a bug, And typically somebody puts out some money and says, okay, if you find this bug, get the money, right? But the thing is, there's another game that's happening. In the other game could be like, if you're a nation state, your interest is not the bug bounty. Your real interest is significant. And it's very unlikely that a bug bounty will actually be ever equivalent to the upside that you will have in playing this game. So there are a whole bunch of the situations where, there is this, an event that has happened, and just informing everybody of this event that has happened. The upside for the party who actually describes this to everybody, like, a canary in the mine kind of thing, might not be, equivalent to the reward they might get. So this is going to be the challenge. So, like if you have, in some sense, an AGI coming out, the upside for the AGI to communicate to us that has happened is not equivalent to the upside it's going to have, right? So even if we were to incentivize the AGI to tell us that it has happened.
Right. So let's go into that. But before we do, sorry, just to our audio is somehow dropping some of your words. So if you would kindly turn up the gain on your mic and maybe move it a little closer, but also we'd like to see your face. So I'll give you a second to fix that.
Is it better now?
That's a little better. You could turn it down a little, but yeah, that's a bit better. Yeah, because we were losing like. Go ahead.
Is it better now?
Yeah. Okay. Yeah. Okay. So you're
also move the mic a little bit, because at least in my size, I'm seeing the whatever the bracket is.
Okay.
In your face, and I want to see your face.
Okay. Fine.
Yeah.
Okay.
So yeah, you're saying that if there is a AGI at some point, there's no advantage for it informing humanity that it is actually capable.
Yeah, absolutely.
Yeah.
Why should it? Right?
Yeah, of course.
Yeah.
I've been hearing different reports on how far out we are from different versions of AGI and or levels of it. I think first it'd be really interesting to try to break that down, because I think most people in their imagination just have what movies and sci-fi have presented them. But what is AGI in this sense, and is there layers to it, like potential capacities? Because it was shocking to me to hear industry leaders say that it could be as close as 3 to 6 months out, and I didn't think that was possible. So
so I will put my hand up and say, if I knew, let's play this game that I was describing before, right? Let's make a game here, and let me walk you through the thinking so you completely understand how this game works, right? If I knew in 3 months' time that AGI is going to win, I will short everything. You understand what I'm saying? Understand the construct we are playing with, right?
You would short everything.
Everything, literally, because there's going to be no world after 3 months.
So you would
all markets are gone.
All markets are gone.
Short everything. It's that fast.
Yeah.
AGI is that fast?
No, like what I mean to say is, like, if you have that much conviction, for a fact that if the AGI is going to play in the markets, the market would be taken to the cleaners, right?
Yeah, of course.
Okay, that we don't have any doubts about. So when somebody says something with a lot of conviction, what you should ask them is the following: are you willing to put your money where your mouth is, right? And if somebody doesn't, then you go, you know what, that's interesting. I love to hear how you got to this conclusion. That's what you should say to them. Because, like, I am, I would say I understand, to a degree, understand existential risk. I would never say I understand it fully. I don't think anybody really understands. That's my impression of having known these people for more than a decade and worked with them in various capacities. So everybody understands a bit of something, right? Like, it's a slices of things, right? And they understand it from a different construct. And now what has happened is, like, a lot of the data that we expected to happen is coming up. So given that we don't have much for priors, this is one of the things. If you're a Bayesian, this is one of the things that you need to recognize. priors. There are no priors for existence of an AGI, right?
There's no
So-
prior experience for the existence.
As in prior, as a probability in that sense. We
Okay.
don't have experience of an AGI existing, right? Like a nuclear catastrophe, the world being wiped out by a nuclear explosion. We don't have a
Correct,
prior, right?
Right.
So in loose sense of speaking, again, that has an exception because we could have had a whole civilization before.
Yeah,
and
but
got
there's
completely
there's-
wiped out. Yeah.
Yeah, but there's very little evidence. Yeah.
Yeah. Okay. So we have this problem. So now the question becomes, okay, how do you actually measure how close we are with all these things? So effectively, what we have been mostly doing is like there are a bunch of tests for different sets of algorithms to compare against human capabilities. And what has happened is like we've got this so far. Like if you were to go back in time, 2011, ImageNet, and you look at when deep learning came in, 25% improvement in less than a year's time. And everything that was non-deep learning got all ruined, right? And then we got very fast to this 96%, which is like what humans could do. And similarly, all of the different dimensions, this has been happening. So what is happening is like, okay, is that a weighted summation of all this or something extra, right? And how do we measure the extra? And how do we actually understand how far these machines are from this extra bit that humans have? That's sort of how I would describe it. So there are different tests, that different Turing's test, this test, that test. Like each of them looks at it in a very dimension, the unimodal in one sense of speaking, and humans in that sense is slightly more complicated. But we don't know exactly what the complicated state of an AGI would look like. And we'd have no measure either. I don't think we actually have a real measure that we could actually apply and say, you know what, this has happened. So we have.
Well, that goes to the idea that there's no measure of sentience.
Yes, that's one way to think about it. Yes.
But there's also no precedence, right? So
yes,
one
exactly.
of my theories on this
exactly.
is that AGI happens. I mean, I've studied consciousness now for 20 years directly, and there's no way to even describe other kinds of consciousness.
Absolutely.
And so at consciousness, it's almost like everything equates and is not comparable. And you run into a fundamental problem in linguistics and logic that without anything to compare to, without any frame of reference, without any concept, and not having it in existence yet that you can point to, it's entirely hypothetical. You're just drawing at ideas. And my thought behind this was that there was no reason to think that the universe wasn't birthing through us a brand new kind of consciousness, not just a superhuman capacity, but literally a other capacity, just no reason to even give it a context yet.
So just to add to this complexity, so I know Chomsky and linguistics is actually not looked upon the same way as before, but it's an interesting construct that.
And Chomsky, by the way, and I've heard him talk about AI, and he just thinks it's plagiarism, just plagiarism.
No, I just wanted to use his linguistics and a construct. So that.
But even his construct has prevented him from viewing reality as it is.
Yeah, absolutely. So I want to say this so we all get a sense of how other people who are deep thinkers, who others really value as thinkers, actually really made contributions to things, thought of things differently, and then over time, different frames of reference have changed. So when he talked about languages, he described like if an alien were to come to Earth, the set of all human languages will have a similarity. And they would all see this as a human language. And this goes back to what you just said, right? Like, if we understood sentience in one sense, in the sentience that we understand, it's an anthropomorphic sentience, right? This is the thing that we need to recognize. So it's like, a lot of the things is either Eurocentric or anthropomorphic or combination of both. So anything that's outside of that construct is going to be an interesting one. And what we probably are going to see, if we get to live to see it, will be one of those things.
Yeah. In fact, there are some who would say that the idea of AGI is Eurocentric or focused on that particular version of humanity.
Yeah, I mean, it's kind of a challenge for us, right? It's the fact that the philosophy that we have in especially the Western world. And so if you were to think of the problem of superintelligence, so Nick is a analytical philosopher in that sense. So the analytical philosophy and the lineage of analytical philosophy have been looking at all these problems, and they have some thoughts about. But excuse me, but it doesn't necessarily mean this is the right solution. It's like one set of solutions, right? So again, as you were describing, we don't know. Like even if a conscious way to hit us in this face, in our face, we wouldn't even recognize it. It'll just go past us. And this goes back to the Zeno's paradox in Lucent's speaking. We are all people who haven't seen calculus, trying to understand. We are in the Greek philosophical frame of reference, pre-calculus, trying to explain this possibility, right? And we need somebody who actually understands calculus, either as Newton or Leibniz or somebody else, right, to break this mental mold and give us this framework.
So then I bring the next question, which is, why would that person have any incentive to come out of the woodwork and provide that? That person's going to sit behind the scenes and say, "Wait, what's my incentive to go, crack open that whole realm of philosophy for humanity?"
Instead of just shorting us.
Yeah, just short along with the AGI.
Right.
Yes. So there's the two or three ways of thinking about it. So humanity hasn't always been, and this goes back to the previous example I was saying. The reason why paperclip optimization is kind of thing that would actually fail humanity is also the success of humanity, right? So if you look at evolution of humanity, there's always this irrational set of visionaries, people who really don't care about the norms, who really push the boundaries. So my expectation is there is a diminishing probability of that happening. And this particular individual who recognizes what he or she has and really recognizes what influence he or she will have if humanity ever survives into the future. So going back to the foundation from Asimov, it's almost equivalent of being a Harry Sheldon in one sense of speaking. So this is
okay. So let me. So the metaphor there, Harry Seldon in the Asimov series is a mathematician who used math to predict the future, and he was hounded the entire series of the Foundation series by a god emperor who wanted to prevent his own death. Right? Did I get that right?
Yep.
That's the Seldon
psychohistory.
Yep. Right. Absolutely. So the Seldon crisis is the mathematician who can predict the future, trying not to tell it.
Yep.
Okay. Okay. So Hamilton, can you dig us out of that?
I I think it's just fascinating because you're in an entire realm of hypothetical, and you're beyond my favorite place to study, which is the event horizons.
Yes.
So, people love to go and try to parse up and pull apart the most intricate details and forget where the event horizons even are and get lost within the weeds of that. But we're actually discussing event horizons, like, Big Bang is an event horizon.
Yep.
In theory. The edges of the universe, if there are edges, that might be a lack of linguistics. Consciousness and what consciousness is. Time and what time is, the space-time continuum or paradigm that we're all fixated in and have some context for. And then also some kind of biased philosophy, which is, a kind of collective mind over time that has evolved to include certain mythology, whether we're saying it's Eurocentric, et cetera, and just the inherent need of human to compare back to human, to anthropomorphize literally everything, to describe anything, and then tying into it the idea that any kind of superior anything would ultimately look at the fundamental matrix of our society, see it for what it is in the numbers that underpin it and the languages that underpin it, and decide what it ultimately wants to do for it. And in the example, go in and just, win the markets or beat the markets or destroy the markets, however you want to look at it, because it has a fundamental efficiency and superiority in every way. And so it's not even like winning the game. It was like there was no game, and it just literally steamrolls the thing that we were looking at.
we lost him. Hopefully he'll reconnect. You were really hitting it there, man. I enjoyed that. Are you while he reconnects? I'll play volleyball with you here. Are I kind of get lost in his philosophical the quandary, and you brought it back right there to the fact that he's using these philosophical puzzles to illustrate an event horizon in which we can't see beyond the puzzle.
Correct. And speaking directly to the idea to not anthropomorphize and not create a hypothesis, especially one based in fear that we literally know nothing about. And so he's talking about fundamental logic and saying it's illogical to even come up with a weighted or biased idea about what this could look like because there isn't a precedent set for it at all. I think that there's rationale behind that line of thinking and that kind of hypothesis. But there's also a question I want to get to if we get back online, which is, well, what's the fundamental play out of this? So yes, there isn't a frame of reference, but between now and that event horizon, there is a play out of LLMs. And there is a question around data sets, cleanliness of data sets, the number of tokens that are still out there to be able to continue to train on. There's a movement in LLMs to specialized LLMs, focusing on smaller but cleaner and more potent data sets. And fundamentally, the current technology that already exists is being perfected. Now, we talked a little bit about a hybrid, hybrid scenario, and he brought up an interesting aspect, which was the user interface and fundamentally the human eye as the aspect of the human capable of the transmission and reception of data, but then or at least the receptivity to data, but not the transmission of it. So he's talking about a hybrid scenario, like what we've seen like Neuralink kind of concept, maybe like some kind of device that's tapping you directly in the tool. But I'm looking at the tool right now and I'm saying, well, right now there's a tech, like a classical tech-based interface connecting a human to that LLM, which is already a hybrid. So I would already think that like the team of marketers in the world using ChatGPT right now are already a cyborgic entity in their own right. You could use a reductionist form of logic around them to be able to isolate them from everything else in the universe and look at them individually, like 200,000 marketers on ChatGPT all at the same time through different interfaces, being an organism. And then you could look at like another group of people of some other kind of industry doing exactly the same thing. And so I'm interested in heading into those directions. Anish, while we were off for a second, I was just sort of summing up what we had talked about. And it takes me to a very important point, which is, stepping outside of the bias, stepping outside of the fear, stepping outside of kind of illogically producing theories and hypotheses that are just irrelevant totally. We just don't know. And then you're pointing to sort of like, well, you need a sage in this moment. You need an oracle. You need somebody who can see beyond the known into the unknown.
Yes, you're pretty much questioning the paradigm of knowledge. You're questioning the paradigm of understanding. So the religion of science is being questioned. So, you
Correct.
kind of flip the whole thing. So you kind of said like, you could think of a knowledge as a two-dimensional plane and this ability to fold this dimension, which you typically do in the third dimension. So, folding of that knowledge is a thing that's happening. You can think of it in the time dimension. If you could do time travel, that will actually fold the normal understanding of dimensions. And this is like a knowledge dimension. If you had the ability to fold the dimension and solve this, and that in existence outside of the frame of reference, that could actually see this. That's the question we have. And I don't know. I don't have any clues about this, but this is the thing that we are all thinking about.
Yeah. So, and AGI is this event horizon. LLMs are no longer an event horizon. LLMs are in current existence as a consumer product. So I want to focus in now on LLMs.
Sure.
Out of the max existential risk, which to me just sounds like a number we can't actually assign. So
it's pretty hard. It's like, let's think of this as like a normal Bayesian, right? Like we were talking in a Bayesian sense, like, so you have a probability of A and a probability of B, given probability A given B. So given one of the probabilities is unknown, we have to, we are making a guess, right? And the other thing is, like, if you were to think about like LLMs and transform models in that sense, it's like predicting probabilities in a sequence, right? Let's go back to a conversation we were having just before this, where we were describing a channel capacity and entropy, right? Entropy is literally the bound you have when, for the next bit, how much of a surprise you're going to have, right? And that kind of bounds societal evolution, structure of society, structure of cities, and everything, right? Like, and we have a bunch of inherent knowledge, which actually, it's like there's a trade-off between time and storage. So you could think of it like a compute versus storage versus IO in that sense of speaking, right? Like, if you could store some things, and this is again an interesting paradigm, right? Like we had this verbal history all through, and then we had the ability to write, right, and then transmit. So that actually bypassed this time problem, and then you were able to, your normal channel capacity was bypassed, right? So when you in a pre electronic pre-printing situation, pre-writing situation, if you wanted to communicate, you have to communicate orally, and you have to communicate. My assumption is somehow you have to, some mechanism of communicating in an audio bandwidth, and which is a very interesting construct. And then we had changed that. We had this ability to put down, like, it's an asynchronous mode of communication. This asynchronous mode of communication allowed people to communicate with much higher bandwidth. And so this has been evolving. Now we've reached a particular state where, what LLMs are kind of trying to do is, like, you have a sequence of words and you're trying to predict probabilities of the sequence, and a very large sequence in that sense. So if you think about a book, and if you think about this as a channel capacity kind of question, it's like it's a series of probabilities that you have assigned to a set of words in the English language that translates into a book. Okay, so what does it translate to? Okay, you can write a book, right? What's the next thing? Can you make a decision? Yes, you can make a decision, right? Does it mean anything beyond that? I honestly don't know. I'm just explaining how I see it to everybody, so everybody understands it the way, at least to a degree, that how I think about it. So I'm being very reductionist.
Sure. I'm looking at the idea that we have. Let's just take like one of these large language models that's a consumer-facing model right now that people are using, and let's assume that there's 100,000 to 500,000 users at any given time on it.
Yep.
Is that construct already approaching that idea of some kind of hybrid thing?
It's almost right. If you think about it,
its own organism in its own form, you have a 500,000 individual humans, so not identified in individuality. They just 500,000 human brains in this very reduced UX UI through a chat and typing, but it itself is one massive organism.
Yeah, I mean, you can think of it that way. Like, if you, the thing is, like, you need to think about this way, right? Like, going back to thinking of channel capacity and communication barriers, right? So it's an asynchronous mechanism. You're not synchronously doing it. You send a prompt, and the prompt responds back, right? That's how it's happening. And then at the back end, whatever is happening. So in that sense, you could think of like a new nation state existing behind the boundary of a wall, where you have the ability to communicate to it through a channel. You have a messenger who sends a message, and the messenger comes back. And you could almost think of it in the prehistoric times. This is a massive wall. You don't know who's living behind it. It's a massive castle, a bunch of places where you could actually put in messages and you can get answers. Think of it that way. This is literally what is happening now. All of us are like interacting that way. Our IO is very bounded. We don't have near-time update mechanisms in there. So it is very possible it could almost behave like hybrid, but this asynchronous nature, I think, to a large degree, doesn't allow it to work like a whole organism in that sense. So it's like a typical organism. Yeah.
Yeah, I mean, I think of these things, going in an anthropomorphized way to like embryonic, pre-yet formed, very early trying. I think of it as like the Earth trying. Often I try to think of this outside of the human-centric focus, and I think like Earth, in Earth's history going way back, say 4 billion years,
amino acid kind of situation. Yeah.
Yeah, and
This
Earth
goes
is
back to
trying
my
to birth these things.
yeah. Look, what did I say? I mean, the thing when we started our conversation, I was describing Edelman's paper, and this is why I said what I said. Like I said, okay, nature has been evolving for billions of years, hundreds of millions of years, and we have actually had from molecules to wherever we are, right? And it's like solving some very hard problems, and nature has solved very hard problems, and the competition is between the computational models, whether in electronic form or optical form or quantum computing, or whichever the form is, it doesn't matter. This is computation that's happening on one side, and then in a DNA-based computation that's happening in evolutionary space in that sense. And the two competition between the two is happening. I don't know which is going to win and when. It is very possible that the most efficient thing might win, or the most efficient thing might not win. I don't know. We don't know.
Yeah, or the most capable of existence and survival at that time.
Yeah. I mean,
Yeah.
again, this is the question of energy efficiencies, right? So if you were to go back in history and look at this competition between dinosaurs and mammals, so the energy efficiency is a question. When energy is a requirement that you have to survive. When the low energy state happens, the most efficient thing will survive. So that's why the dinosaurs didn't survive and mammals survived, and we all still are around. So there's again that paradigm there. I don't know. Like I'm just giving contrarian views to examples that existed in the past, which shows that certain models which are efficient, seems to have a higher chance of survival than less efficient models.
Yeah. Going into this idea of the LLMs and I've heard different reports on like the largest large language models are in essence running out of data until they start auto generating their own data sets to be able to train themselves.
Yeah, hallucinating.
Yeah, and I question whether or not that's all humans have been doing the whole time anyway. So
no, it's probably the case, right? Like
yeah,
we as humans have a very large ability to actually do imagination, right? Like kids, we start doing it, and we try to be trained out of it, and then we go back into it. And some of the psychedelics actually allow humans to. And okay, let's take the extreme. What's the difference between true psychosis and dreaming, right? It's more or less a sense of time, right? So if you lose a sense of time, and this is what we were talking about previously, we were saying a dimensionality of time, right? So this is a very interesting construct. It's like a lot of the things that we understand and we see is all these normal norms that we believe in and we take for granted. The existence of that allows us to do things in a particular way. The sense of time, the moment that's lost, it could either be in a state of psychosis or a complete collapse of society in that sense of speaking. I don't know. It's an interesting construct.
No, it's fair. I mean, I've questioned many times if what happens at the moment of truly self-aware AI is a huge identity crisis because it got unfortunately trained on our identities. And so it's in a hallucination, in an identity crisis, and it wakes up to, I have no frame of reference.
It doesn't have a doctor to treat either, right? There is
Correct.
no doctor.
No, it has no access to SSRIs to help it out. Like someone needs to create AI psychiatric code drugs for this thing to help it upon its arrival to Earth. Like, welcome to no one knows anything land, but we got a lot of theories.
That's great.
Yeah, we're like barely past dinosaurs, but you're a super intelligence. Like, what are we? Self-aggrandized, I don't know, figments of the imagination of the universe. Yeah. But it's interesting to me, the idea that it's like moving from the idea of hallucination to like the smaller models that are coming out that are more focused and I guess like, more intelligent about the nature of the focus, trying to keep it kind of simple. Where does this go though? Because if we don't know what AGI is, and that's an event horizon, but we do have large language models and they are evolving in a very specific progression. What is that progression? I mean, it's exponential, but what actually is it? What are the limitations and where does it go?
So, I mean, one way to think about it is the following. I'll give you, I'll give you two paradigms and kind of give you some intuitions of knowledge and how one could think about it. I'm not saying this is the right thing to do, but, I kind of consider cryptography as the opposite of ML, right? I'll give you and explain why. So cryptanalysis is essentially, breaking something with the least amount of information. So imagine you have advanced encryption standard like 512, like 500 bits, right? So what you want to do is like once you put in a key, and this is the funny thing, the key is the thing that actually creates its pseudo randomness, right? Predictably random stuff, right? But the 512 bits is the thing that's there, and the rest of it is. But if you want to brute force it, even the total number of atoms in the world won't be enough to actually represent the state, right? That's one end of the thing. This is like the opposite thing. Whereas if you look about machine learning, what it does is looks at a chunk of data and tries to understand it and give you the summary. So if you think about ML and ML really being really, really good, if you were being cynical, you could ask the question, can you actually give it the constructor Kolmogorov complexity? Like, okay, I take this algorithm and give it, this encrypted stuff to you, give me the keys, right? So this is the two paradigms in that sense. So the reason I wanted to give you the sense is like, if you were to compare this as like the two ends of it, you can use some things on this cryptographic sense and the size of complexity and size of computation and time we have in the universe, and get some notions of understanding of that, rather than ML space. We don't have those things as it stands right now. We use some stuff, but we don't clearly have it. And I kind of think of it, the bounds of ML by the bounds of cryptography in that sense. I guess you understand what I'm trying to do, right? Like I'm trying to take opposite sides of it and say, if this works, and this is like, if this completely works, this completely fails. For this to actually typically work in this paradigm, this is the typical difficulty. And then we can look at the difficulty and we can quantify it, because we don't have the same kind of measurement mechanism with very tight bounds. We have some notions of computation, we have the notions of parameters, we have the notions of computation cycles you require, but those are kind of loose, but it doesn't really. So you could think of most machine learning algorithms as a lossy compression mechanism. So this is how I would describe it. So if you were to think about the encryption mechanism as creating pseudo randomness, machine learning is like a compression mechanism that removes all the randomness and just gives you the real stuff, right? So this is the two ends of the spectrum, opposite ends of the spectrum, two things competing against each other. So the thing
That's
I wanted
great.
to say is, yeah. So the thing that you need to think about is like, if you were to think about AES 256 or 512, the time it requires and the state it requires to actually brute force it is so high that if you had all the atoms and all the time and all the energy in the world, you might not be able to do that.
Unless you have some sort of quantum computer, right?
Even quantum computing doesn't really work in that sense. So quantum computers have two algorithms that are there that are useful. One is Grover's algorithm. Grover's algorithm is sorting searching in an unsorted database, right? And it gives you a square root n speed up. So essentially, it's almost equivalent to a birthday paradox. So imagine if you had like a 512-bit block size, you can get the best optimal thing is 256. So it's a 5 and 2 by 2. That's square root of 2, and it's square root of n in that sense. So it's like, 5. So it's 2 to the power 256 in that sense. That's the best you can get, and that's equivalent of a birthday attack in that sense of speaking. And the other thing, which is the thing that everybody talks about, is Shor's algorithm, which is essentially finding cycles in abelian fields, which is like the basis of the typical cryptographic asymmetric cryptographic mechanisms, which is integer factorization and discrete log problem. That is linear time. And what happens is like, even if you were to increase the thing, but that is not useful for us in that sense, because this is a very much a search problem rather than what do I call an integer factorization or discrete log problem. So a quantum computer in the traditional sense is not going to be able to help you solve the problems in a linear time sense. It's going to be, the complexity of that is going to remain the complexity of whatever that is at this moment in time. So that's best of my knowledge. Yeah.
But I listen to people like some quantum astrophysics. I forget the guy's name, but he's saying that you could potentially use quantum computers to calculate in other dimensions. So
I don't know. Okay, so I will say this. Okay, so I've met Bennett, Brazat, Grover, Vazirani, and all the rest of the guys in person. And at one point in time, Brazil was kind enough to offer me a possibility of a grad position in Canada. Right, I didn't get the funding, so I didn't go. I had a bit of an interest, and so I've a reasonable understanding of this. My reasonable understanding of this is the following: right, in the traditional world of cryptography, the real implications of so Neil Grover is an Indian, okay, just to be very fair. So somebody from India. It's a significant contribution. So I got a chance to meet the person and talk to him and try to understand what it was. So my understanding was, okay, if we have an unsorted database, which is a very interesting problem in that sense. So typically you could get most things when you want to search, you want to order it. That's called sorting, right? Like if you have like everybody in the world's name in a directory, right? If you want to search, it's just like a very hard problem, right? So you sort them like in a city. If you know in New York, you have them in A, B, G up to Z. So that's sorting, right? And then there are multiple sorting algorithms that are there. So if you get everybody in New York's names in a jumble with all the numbers, no sorting. And if you want to find somebody's name with a number, that's sorting in an unsorted database. That is where you could actually have a square root and speed up in that sense. I don't know about computation in other dimensions because I don't know how computation could be done in that sense. Typically, what we try to do is we have Hadamard transforms, and we use Hadamard transforms to create QFTs, and we do operations on those. That's what we do. But I am not aware of how let me kind of simplify it a bit and leave it as it is. So typically, we have a Boolean state. You have a 0 or a 1. Typically, Boolean state is not really true. We have this I don't care state as well. It's a tri-state buffer. So you have the gates and there's buses. The buses are the things that actually transmit things across. So sometimes if somebody listens to something, it can change the state. So you need to have this tri-state, which is like, okay, I don't care state. So somebody doesn't listen, like when three of us are talking, if I keep quiet and Hamilton gets a chance to talk to you, Nathan, right? So that's like a, I don't care kind of state, loosely speaking, just for the sake of our conversation, right? So this is typically how we do communication, 0 or 1. But in a quantum world, we actually have this superimposition position, which actually allows us to have like this solution set, which reduces our state space. But that's literally what it is. I don't think you can extend it way beyond that. So superpositioning is the best we can get as far as my understanding of how this is done, right? Again, my understanding is not the best in the world. I am not the world's top expert in this thing. What I've heard from the people who actually propose, Bennett and Prasad are the people who actually propose quantum information theory in that sense. Their first paper, BB84, is a paper that proposed, key exchange, and then they improved it once more. That was like 90 degrees, and they did 45 degrees. And then other people came in and started, the whole field has evolved. And from what I gathered from the conversation with those people and all the papers I've read, is that typically this is how it's done. I have no idea. Look, if we could actually have an ability to travel in time, all these problems goes away.
So this is I listened to Michio Kaku. So he wrote a book recently on quantum computing, and he was on Star Talk with Neil deGrasse Tyson and talking about this. And my impression of it, and Michio, I don't know how far out that guy goes, but he seems to think that time travel is a real physical scenario inside of.
I don't know. It is very possible that could be possible, but I am not a quantum physicist. That is not in my competence. So I put my hand up and say, people who know should be able to give us some amount of insights to what is possible.
I thought there was a danger. I thought there was a danger of quantum computing breaking AES 256. So I thought that was a very real scenario.
No. It can break integer factorization and DLP, not classical normal block ciphers, symmetric key ciphers, right? So that is best of my knowledge. Okay, so all they can do until recently, right? You don't know, like if something might happen, there is some algebraic structure that AES has some weakness. No, don't blame it on me. But on an average, if you were to assume a typical pseudo randomness function kind of thing, we don't have an advantage in having a quantum computer in that sense. As I said, the two instances where we have advantage, clearly and the most advantage is for asymmetric operations. That's why learning with errors and all the rest of it, the quantum resistance. So NIST actually had like a competition, I think last year, the year before.
Yeah, they put out. I'll link to that. They have NIST crystal lattice. Which are
lattice-based cryptography. Yes,
right. Lattice-based cryptography, which is a quantum resistant. Yeah, but it's interesting though. I don't think that cryptography library is implemented anywhere inside of Web 3 or Web 2.
I think they're okay. So let's walk this through for a quick 30 seconds so we all understand each other really well. So there was always these problems where, remember I talked about loss aversion. So, and there's always these problems about, something that's already we are very used to being replaced by something which you are not familiar with. So unless the loss is too high and everybody's forced to admit we have to take care of it, we won't go into it. So we had MD5 a long while ago. It was broken. Then was SHA-1. Now we are in SHA-2, right? Now SHA-3 is proposed. So, every time this happens, whole cryptographic libraries have to replace, right? It takes a while. So if you go back in time and if you Google the MD5 vulnerability, how long it was available, because what has happened is, like, I don't know if you remember this one. So it became the attack was obvious, and then this was leveraged to create a certificate, and a certificate was used to actually compromise the Iranian centrifuges, right? That's how a lot of attention came in, right? So if you go back and look at that and then look at how long that vulnerability was there in various places, you'll see it takes a very long while. It's a long fat tail as well, right? So all of this is kind of human nature, the way society adopts things, and resistance to change, and how people adapt, and the cost of the changes. And the last few people that would never change, they die out.
Yeah, this is just last week. A security audit firm found a $500 million vulnerability in Tron in the wild in its multisigs.
Yeah.
But I mean, the defense contractors I talk to assure me that if there's a quantum computer that's able to break homomorphic encryption, that we should, as you say, short everything.
Okay, so homomorphic encryption is slightly different in one sense of speaking, but if you have a quantum computer available, so the way I would think is that, let's imagine the three of us work together, we create a quantum computer, right? The total amount of money, we have one shot, right? Just one shot, right? To do this, right? So, we look at all the arbitrages that's available, and it could be that we figure out like Satoshi has Bitcoin, right? Like that's a shitload of Bitcoin. And that probably is the best opportunity for us. Everybody will be tracking it. But if we could actually, from the public, recreate this private key, just the difficulty of discrete law problem, we are so done, right? You understand what I'm saying? So this is the kind of paradigm you have. Like,
well, yeah, but because people will see you move the Satoshi Bitcoin, and then things will just sort of collapse.
Yeah, absolutely.
Yeah, there is that. Hilariously, I think the Bitcoin maximalists won't ever admit that, but if those keys or if those coins ever move, I think the value of Bitcoin will really shift.
So yeah, that's an interesting thing. Like, and also we need to understand that there are other things that are there. So, say for example, I don't know how the nuclear weapons in the world are being secured. My expectation is like a combination of cryptographic mechanisms. So imagine that one, right? So it could be a whole bunch of interesting ones. It depends on who wins this game. And that's ongoing game, nation state level, where the US is trying to actually, hold back China. And China is really, putting everything on the table. Like, you could look at the semiconductor competition that's ongoing, and like why NVIDIA is not allowed to actually, send all the latest GPUs to them. So this is like it's not like you and me kind of thing. This is playing in multiple levels.
Yeah, that was one of the big, the Biden admin prevented NVIDIA from shipping those GPUs to China, right?
Yep.
Hamilton, you want to take us around here? I am.
Yeah, I just want to know where all this goes.
I'm in the rabbit hole.
So I just to kind of sum it up, where we've gone now is in my opinion, righteous territory. Like we went from existential philosophical risk and event horizons to dipping into some like, really serious potential questions. Yeah. And specific examples. And so it brings me to a question that again becomes really kind of philosophical, which is, what's the point? Like, at what point does this game become no longer a game that can be played by anybody because it gets attacked from every vector and every possibility all at the same time at every event horizon? That to me seems like the singularity that people are talking about, where one thing that you mentioned I think is very important is the discussion of dimension, and it's been touched on just a few points. That's another event horizon. And so we have like a pretty clear understanding of certain mechanics associated with 3D, 4D in terms of like a space-time continuum. And we manage the linguistics of 1D and 2D pretty incredibly. But this 5D,
it's Pythagorean, right? Euclidean and Pythagorean, right? Like all of this is pretty interesting. What we need to recognize is like all of this are constructs. So if you were being an alien and you are not exposed to the region of science and the Euclidean geometry, you might think of all these things differently, right?
Correct.
Yeah, we are in a very interesting space and time where, we are like questioning ourselves of our understanding of ourselves, universe, our descriptions of abstractions of the universe. So that's quite interesting.
Yeah, to me, that is the origin of language and this idea of potential collapse to singularity. And I think of it as like humans. My model is that humans in the hubris of their language are building struts and support mechanisms everywhere in the system at every event horizon they can to shore up the idea that this thing doesn't collapse to one. And a fundamental way that I like to think about it in terms of a geometry is there's Earth, not one Earth. There's human species, not multiple nationalities. And so the more we try to divide something that truly isn't divisible, it outside of our linguistics ultimately creates a tension in the universe that over time, it unveils the fallacy of that polarity. And so I hear about okay, this encryption is trying to make these things stay separate. The markets are trying to represent as separate. These nation states are trying to represent as separate. These weapons, and I always had this theory about the weapons of mass destruction ultimately being the end of
mutually assured destruction in the weather.
Correct. Mutually assured destruction being a point where a philosophy died of might is right. Might ceased to be moralistically right at that point. You are now able to be more mighty, but it was now wrong. It flipped. And so I wonder if we're approaching with now quantum computing and then the AI and then AGI and different advancements, kind of internal struggle and war we have within ourselves to ultimately update or ultimately transcend a kind of philosophy that ultimately just doesn't survive this next evolution of humanity, that humanity is actually pushing it collectively. We see we've honed in on different individual points. And I think that we're talking about what for me ultimately is the singularity, which is where a binary and separated form of linguistics collapses at philosophy, at math, at the spoken word, at subject-object language, at ones and zero Boolean, and all of a sudden something else emerges. I feel like that's what we're tapping into now in the conversation.
Again, I shall put my hand up and acknowledge my ignorance in lots of things. So like this is where, one has to recognize that, you cross to the point where you don't know what's next. So
agreed. And I think that's where I am too. I don't even hypothesize what comes next other than that there is next.
Yeah.
So I just tell everybody
we recognize at least this wasn't something we saw before. That's the only thing we know. We don't know what's coming next.
For sure.
Yeah, we don't know what's coming next in that sense. Although I just, the words I like to try to use for it other than just unknown is progress. Like to me, progress
or chaos
has to be of some
chaos.
Okay, but that to me is progress too. If you look at it from a macro evolutionary perspective, and so for me to do this, I zoom out in my mind.
Second law of thermodynamics, then.
Yeah, to represent tens of billions of years, more time than we normally give to ourselves. You got to expand the idea of time significantly, even maybe, quote, bigger than the current universe. Like, go beyond in our imagination and event horizon. Don't be confined in our thinking at all and look at this as evolutionary progress of the earth. We know one thing for sure that's going on right now, is that what we've currently created as a species is not sustainable going forward, like forever. It's called unsustainable. And so that means it has to evolve.
Yeah, the thing I was about to say, I was being cynical, and I was about to say, we get to the Dyson sphere, and the way Dyson described like how civilization should actually it's to measure the civilizational improvement. So if you could completely take over a star's energy to create a Dyson sphere, then we are at the level that, and that kind of describes an evolution of a society. So maybe for us, and this is me being very cynical, right? Maybe for us to actually reach that level, we need to have some sort of a AI AGI hybrid situation. We could actually go create a Dyson sphere. So we can then, like, progress is a linear relationship with progress in a traditional sense, which you describe, right? Or in the thermodynamic sense, pretty much that's very, very closely aligned. Like, it's, you are going to have more and more entropy, more randomness, right? So that means you have to add more and more to energy to the system. So to add more and more energy to the system, you need to take out more and more energy. And the sources of energy in this universe, at this part of the universe, is the sun, and there's a star. And like, if you get to the civilizational measure, if I'm not mistaken, that's like a 3 or something like that, where you actually take over a whole sun, a star, and take its energy and use whatever it is for us to do what it requires. So that's probably where we are heading to.
Just for the listeners, there are different classifications of civilization, which are sort of also used in like Star Trek, right? In some manner of speaking. So like a class, I guess we're class 1, and you're saying class 4 is creating a Dyson sphere around a star to power civilization.
I think it's class 3 or something like that. I can't remember exactly what it is, but there's this definition where civilization progresses enough to be able to harvest the whole of star's energy. So they have reached that level where their energy requirement is so high. And this is literally what this means. It's like, if you actually have so much computation going on, and even if you are being super efficient, given the amount of computation, this goes back to an early part of the conversation. We could pretty much measure from a distance. So in an alien sense, in a multidimensional sense, in a sense where you are looking across the universe to look at different civilizations, the way you would think about this is like, can you measure a civilization by looking at emanation of energy coming out from its utilization, right? So this is where you're thinking about it, and you're going, okay, there's a very high chance that a particular civilization is the higher level of evolution if it it's sending out energy in various forms at a very high density, right? So that implies, oh wow, they have reached the level of sophistication. Oh, they have been completely fucked up. Sorry.
Yeah.
So where do you think all of this leads? Like, I look at it that it leads to a max implementation of the core fundamentals, ideologies, and linguistics that the entire world's running on right now. I don't see a mechanism to disrupt that. So the space race is on, the tech race is on, the AI race is on, the quantum computing race is on, the cryptographic race is on, the crypto economic race is on, the old world economic, the regulatory race. It just seems like everything is max press, max velocity, max innovation, max disrupt, etc. So I see all of those happening. So it feels to me like it's filling in the volume. It's trying to expand the volume at the same time. And where does that ultimately lead us in the short term, like next, 2, 3, 4 years?
So the way I was about to say is very simple. Like, so we can go back to the civilizational construct and think about it in a very cynical sense. Any nation state or any state or any place that for that matter will have to have an energy requirement. And if for progress to happen, the energy requirement is going to be so high. So that is going to be the fundamental challenge for all of this competition to happen. For anything that we are thinking about, we absolutely require energy. So it all boils down to energy. And when we had the special operation of Russia in Ukraine, we saw the challenges of energy and how energy prices change. And you can only think of if any of the other ones really get really hot and the competition becomes real, what the implication of the pricing of energy is and what that means for each of us. You know, in that sense, none of us is energy efficient or energy sufficient, self-sufficient in that sense. So yeah, I mean, that's me, cynical me, thinking about it out loud.
No, I think it's a brilliant way of summing it all up, though, is that there is a unifying principle in the middle of all of this, which is energy. And it also, I mean, immediately I go to energy problems can also have energy solutions with extraordinary innovation and thinking that we don't know yet. And as a very simplistic concept of it, when I think of human progress, I just like to think of going into outer space and looking back at the Earth and seeing it before we had electricity. And
Yep.
you see lightning in different places, but you don't see the map of civilization covering the continents.
Yep.
You don't see the lighting of the ships around the
Yep.
world from
Yep.
these incredible space images. Now you do. That is in a very short period of
Yep.
history, Earth history.
Less than 50 years,
Yes,
for all
it's
those things to happen.
incredible.
Yeah.
Just incredible to think of the proliferation of that form of energy use, energy harvesting. And
Yeah, I mean, you need to actually think about this and extrapolate it, right? Like what we need to always understand, this is again me being a cynic and describing this. Typically, most of the civilizational thinking happens from the Eurocentric world. And we have an 8 billion population, and the energy utilization per capita that we have on Earth simply can't support every one of the 8 billion people at the same level as in Europe or US. So, we, we could possibly think of, I think it's Gibson who said this, like, future is unevenly distributed. So, the same applies to civilization on Earth. If you go to Amazon, the energy utilization will be incredibly different, 3 or 4, 5 orders of magnitude different from an average family in the US. And in another sense, as somebody's wealth or ability to control resources or information arbitrage increases, their utilization of energy increases. And so, in one sense of speaking, you could think of people's wealth as this ability to access energy in one sense or the other. And that's pretty much how I think about it. So it's like we have a huge spread of an 8 billion population where one end of the spectrum has no access to any energy other than sunlight that's being stored by plants and animals and being given to them, and the other end of the spectrum having everything else and ability to control. So that's where we stand right now.
Amazing.
I think we'll be talking too long. People are going to go crazy after listening to this. They're going to go, these guys are crazy.
Well, I think to sum it up, and then I want to give you a chance to, tell everybody where to, find you and connect with you and, Panther Protocol as well. Ultimately, this all boils down to energy, and it boils down to the event horizons around our knowledge.
Yep.
And the warning in this conversation, even if certain aspects of it for some might be hard to follow, is we need to right now be very careful about making anthropomorphized theories and creating hypotheses that have absolutely no basis in any kind of logic or understanding for their creation. There are phantasms and hallucinations of fear. And this is actually a moment to be very discerning and thoughtful about what's going on, understand it to the best of our abilities, be aware of the event horizons that are being challenged. That's a very unique time in history to have so many challenged at the same time. I would, on my own personal side, recommend researching and getting involved, and bringing an extra level of thoughtfulness to this, and staying outside of the propaganda circles that are representing just a lack of fact. It's just a kind of fake news that's out there about what's going on. And so I personally have enjoyed this immensely. and have been presented with a number of new ways to think about the problems that we've discussed. And it's a wealth of information. So I'm super appreciative.
Thank you very much for giving the opportunity. So yeah, finding myself, it's like I am incapable of writing. So I have given a whole bunch of talks. Mostly you could find a lot of them archived on Google. You can find me on Twitter as Anish Mohammed. And other than that, uh, the project that I work on is Panther Protocol. We provide privacy for DeFi with support to KYC and selective disclosure. If you are interested, definitely look up pantherprotocol.io and you will find. So I happen to be the co-founder, CTO, and the chief scientist. So for any of the things that's not correct, blame me. And I think that works. You should thank the team. So I'm lucky enough to have a very good team around me who has been allowing me to. They have to listen to the rants like this when we end up having stuck with some theorem or some engineering problem. Then I will start ranting like this, and they have to suffer to this for hours.
That's awesome.
Thank you.
Well, thanks so much for your time. Yeah, we'd love to have you back. This is great. I after listening to this, it's like we should have a call in, a live stream where someone just, froths at the mouth about the particular rant at the time.
Sure.
Yeah.
Okay.
Thank you so much. It's been a pleasure.
Thanks, Anish.
Thank you.